20, 30, 40.
Okay.
And then 3 plus, you take 3 and then take 3 equals 6.
Oh my goodness. You must have a really good first grade teacher, Jeremiah. Miss Herring has really done her work. I love that you split 3 and 3 more instead of just 1, 2, 3, 4, 5, 6, which could happen, and that's fantastic. But the fact that you did it that way made it faster. We call that efficiency.
3 plus 3 equals 6, and then 46.
46. Do you see how he didn't even have to count one by one? He could have, though. That's an excellent way to do that. Nothing wrong with that at all, is there? We all have different levels of understanding. Once your students get beyond this, and they're really good at it, certainly as Jeremiah is, it's now time to do 2-digit plus 2-digit, again, with maybe bigger numbers. You ready to do bigger numbers now? All right, so this would be the last stage, I would think, of understanding before you move into moving on up in the place value, so working with hundreds. And that's how I would challenge those kids who do come to you ready to go and maybe on their pre-test get 100% on the adding. So I would just move them into the hundreds. All right, Jeremiah, you have already shown us 46, so I'm going to keep 46 there, Jeremiah. And I'm going to add a different number. I'd like to add 28. Okay? 46 plus 28. Now, Jeremiah, you're just going to do the same thing you did when you built this number, 46, and then you're going to build the next number down below, just like you did. All right, show me that. Show me 46 plus 28 down here. Can you count out loud so that the camera people can hear you?
10, 20, 30, 40.
Okay, look here, sweetie. I'm sorry. This one's already done for you. I love that you're going to build 46 again. But we've already got 46. I already did that for you. So which one do you need to build now?
20.
You built 28. There you go.
10, 20, then take 8.
Out loud.
1, 2, 3, 4, 5, 6, 7, 8.
Again, notice the organization that he uses to place his counters so that he can clearly see that that's 8. And that's what I was going to say next, but he already fixed it. He understands place value. He understands that the 1s go over here, the 10s go over here, and that we need to keep them organized that way. Very good, Jeremiah. So now we have all of these things here, 46 plus 28. I'm just curious what you'll do. If you see this, what will you do? Let's first, before you do that, because this is what I want you to do. Look at me. I do want you to do this, but I'm just curious. I don't know what you're going to do with this. What if you just had to do this? How would you solve that?
4, 5, 6.
All right, show me. And this is why we do conceptual understanding before procedural.
4 plus 2 equals 6. And 6. Wait.
Okay, so we've already got that part. So you can just put your 6 down here. All right. Now what do you do?
And 6 plus 8. That's a really hard number. So, 6 plus 6, 3 plus 3 equals 6. So
6 plus 6 is?
12.
Okay.
12, and 6, and then 6, 7, 8, that's 2. So 6, 12, 13, 14.
Unbelievable, you're so smart. Okay. Okay. I want to show the camera what you did. Isn't he so smart? He's so smart. This is why I don't teach conceptually, though. Or, sorry, procedural first. This will come. And I know he has a solid understanding of 10s and 1s. Let's see how it changes. Let's see how his mind changes when he uses the manipulatives. All right, Jeremiah. Now I want you to, listen, do you know what that number is?
614.
Oh my gosh. Seriously? But you're only 6. How do you know that?
I don't know. And,
Smart cookie.
And it could be 6104.
You think so? Okay. Now, we're going to put that aside. Let's prove it. How will you combine this, Jeremiah? What will you do? Ah, same process as before, right? That's a lot of counters, huh? Talk us through what you're thinking here now. What are you doing here?
I'm doing something.
You're lining them up, aren't you? To make what? Kind of partners, so you can add by 2s? Okay, so now what?
3 plus 3 equals 6. 60 and 30. And then 3, 6. So now you know it's 60.
Because there are 3 10s and 3 more 10s, that's a very fast way to do it. That's efficient. Yes, that's 60.
And then 3 plus 3 is 6. 7, 8, 9, 10. So take this. This is 4. Then you trade this. It's one of these 10. Then there was 6 here. Now there's 7. Now there's 4.
Okay, so what is the answer?
64.
Okay, prove it.
3 plus 3 equals 6. 3 plus 3.
3
3.
plus 3 equals 6.
And then there's one right here that haven't been counted. And now 6, 7.
7.
And then now it's 70.
So 70,
74.
74. Is that the same answer that you got here? Which one's right? How do you know?
Because this is better than that.
You proved it, didn't you? Here you didn't prove it. You weren't really sure. You made an awesome guess. 74 is the right answer. And so my question to you is, why didn't that work? Do you remember? How many digits can sit in each place? 1 digit in each place? Just like if we're looking at the hundreds, tens, and ones, how many digits can sit in the ones place? Only 1. How many digits can sit in the tens place? How many digits? How many numbers? Okay, tens, that's a 2-digit number, but look, Jeremiah. Only 1 at a time can sit here. It could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Can it be 10 sitting right here?
So there's 10 numbers.
Can a 10 sit right here? Can I write a 10 in this spot? Can I write a 10 in the tens place?
No, but there's still 10 because 0.
There's still a 10 right now. I understand what you're saying. That's 10. There's 1 10. Yeah. But you can only write 1 digit at a time. That's what happened here. That's what happened. And just so you know here, Jeremiah, look at this number. What's that number?
14.
14. Where's the tens in 14? Point to it. Yeah. So then what you can do is say, hey, whoops, I was supposed to put that guy with this guy. Because that's the tens place.
So 6 plus 1 equals 7.
So 6 plus 1 equals 7. And there's 7 right there. So that is how you proved it and made it make sense. Jeremiah, is it still 4 ones? Yeah. You are awesome. Give me 5. Smart cookie.